For this section, it's very important to understand the difference between mass versus weight. So, how are weight and mass different? 1. Mass is a measurement of the amount of matter something contains, while weight is the measurement of the pull of gravity on an object. 2. Mass is measured by using a balance, comparing a known amount of matter to an unknown amount of matter. Weight is measured on a scale, usually by action of a spring. The mass of an object does not change when an object's location changes. Weight, on the other hand, does change with location, and this is important. So when we're looking at this, okay, so if I have a cube, has a mass of 90.91 kilograms and a weight of 200 pounds on Earth. Now, so on Earth, we think of those as being equivalent values and just in different units, but they're not actually. So the moon's gravity is a little bit less than a quarter of Earth. In fact, it is 0.165 of Earth. And gravity affects weight, it does not affect mass. So the mass of this object on the moon is going to be 90.91. And we can submit that, and it tells us, yes, I am correct. However, the weight of this object is not the same on the moon. Pounds, X amount of gravity. That doesn't really give me very good feedback, but the answer is that's wrong. How come? So let's take a look at this. What we need to do is take the weight of my object, 200, and multiply it times the effect, the relative effect of gravity, which is 0.165 times gravity of Earth. And this object's only going to weigh 33 pounds on the moon. Oops, 33. So this is really an important concept, that weight changes as gravity changes, mass does not. Why is this so important to this section? Because what you might notice on this section is when you're doing force equals mass times acceleration, and you want to apply that when something's measured in pounds. The thing is, pounds is a force. It's not a mass. So, if I'm talking about the force equals mass times acceleration, and we're talking about a 200-pound object, then that force is 200 pounds. That object has 200 pounds of force. So if you're carrying that, it takes 200 pounds of force to carry that object in your hand. Yet, when we were looking at that, that object had a mass of 90.91, and this is 200 pounds of force. So 90.91, if you're trying to hold that up, then it's going to be just holding it steady means I'm fighting gravity, which it has 9.8. Let me double check that. I always forget that. Acceleration due to gravity. I think it's 9.8. Due to gravity. Google, you're so good. Okay. Just give it to me real quick here. 9.8 meters per second squared. Okay. And so the force measured in the metric units is 90.91 times 9.8. That has a force of 890.918, and these are called joules. What was it? 890. Sorry about that. .918. I'm sorry, not joules, newtons, isn't it? Newtons. Yeah, newtons of force. Force is measured in newtons. And that would be the force to keep something 200 pounds. Holding it, you would require 890.918 newtons. So, again, when you're talking about pounds, it's not just a difference in unit, it's a difference of how we look at those units. One is a force, one is a mass. So really it would be more equivalent to say that 200 pounds is equivalent to 890.918 newtons. Now we're really talking about the same thing. Pounds and newtons are much more equivalent measurement. They are the same. They're just a difference in unit, not pounds and kilograms. Hope that helps you with this section.